without
yeah. Physics, but I guess what I'm saying is that if a system is complex enough, then it's not always clear that the lowest level of description is the best level of abstraction for understanding the behavior of that system. So, for instance, in my coffee example, the lowest level was
or a quark.
That's not a very good description of what.
Right. So I will argue with you on that one that I would agree that looking at a complex phenotype, just going to the DNA and just reading out the DNA in a digital form, there's no direct link. I agree with that entirely. But in terms of trying to understand how phenotypic complexity arises in an evolutionary sense, in a mechanistic sense, I don't see any alternative than thinking about evolution in terms of change. And you could change this word gene if you'd like, because it's become increasingly fuzzy what we even mean by a gene, but it's change in nucleotide frequencies. Not individually, often in the ensembles if they're linked together and so on, but to me that's where the real mechanisms are. Okay? I'm not saying that you can understand the emergence of complex phenotypes without thinking about gene interactions and things, which starts to get into higher order sorts of things. So maybe we're not really on that different pages after all, but
we are. But I'm just wondering, are you?
But you can go to plenty of these books. Well, some of these are just nonsense books, but there's other by quite reputable folks.
Gene, I read that. I thought that was a wonderful book.
It's very well written, let me put it that way. Dawkins is a great writer, but Dawkins has not put much effort into keeping up with the modern field of evolutionary biology.
Well, that was written many.
Right, but he writes a book every 6 months, and I would say the same thing about the book he wrote only a few months ago. He's a very good publicist of science, and we need people like that.
Well,
but
erase all his other books, but in that book he's saying, well, the Darwinian ideas apply just as well at higher levels, because all the ingredients
so
go into his explanation, replicator, selection, and so on, apply at these other levels as well. So
where I and a few others would depart from Dawkins is, and this is this problem that I was pointing about before, this myth that evolution is natural selection and only natural selection. That's Dawkins. Okay, for a while, Stephen Jay Gould's not alive anymore, but he's the other guy who wrote, the big popular books, and, Gould was on the other side of the coin. But you never really knew what Gould was talking about. I mean, Gould really, he's a great writer, but Gould never made any effort to really understand modern-day evolutionary biology. This book is called The Structure of Evolutionary Theory. It's quite amazing. I'm not sure anybody has read the book in its entirety. I've tried, and I know many people have tried. It's like 2,000 pages. There's not a single reference in this book to modern evolutionary theory. It's really remarkable. But you can go to some of these other books, like Gerhard Kirchner, for example. Many of these other Evo books, they will all argue that evolutionary theory is completely lacking in credibility when it comes to understanding evolutionary development. They'll just come out and say we need to dismantle the entire theoretical edifice and start from scratch. Those statements are made probably more strongly than Carroll was making them in books like this. Okay? It's a common feeling among at least evolutionary developmental biologists. And that's been going on for a long time. There was this big, those of you who paid attention to the history of biology know there was this big schism between the geneticists and the developmental biologists at the beginning of last century. Genetics and everybody else sort of went this way, and developmental biologists went down this narrow trajectory and worried about things like hopeful monsters and stuff like that.
All right, well, I'm sorry to derail.
No, I think it's good to get some of these points out now, because I think they probably are going to come up. Of course, we only have a small subset of the audience that is going to be here, but one issue about cell biology, which we just encountered, is many of the structures that you start looking at, like the nuclear pore complex, It's just this big complex structure. And without a lot of good comparative biology to start with, it's really difficult to even figure out, what are the evolutionary questions that we can even ask, and what would an evolutionary cell biology even look like as a science?
But just maybe to interpret the idea, these two extremes are not the only things playing here. So, for example, there